expressed in this show belong to the person expressing them. They do not purport to reflect the opinions or views of Rancher or any other entity.
Hello and welcome, everyone. Welcome to episode 2 of what I'm affectionately referring to as Shipwreck's Sunken Treasure, because I spend the week going through one of the tool of the days, maybe many of the tool of the days that Adrian posts, and I spend a lot of time and I allow you guys to learn off of my mistakes and show you the highlights of what I've done over the last couple hours. So, thank you all for joining. I'm hoping that the last episode was useful for everybody. Last episode, in case anybody missed it, was on using Helm, creating GitHub Helm repositories using GitHub Actions. And today's show, as you can tell by the listing behind me, is going to be crew related. So crew, if you're not aware, is the way that you can add plugin extensions to Kubernetes. Crew is going to give you the ability to essentially write something in Go, write something in any language for that matter, dump it into a specified directory, and then make it available to anybody that's running Kubernetes in that user environment. Adrian posted something yesterday in that you don't really need crew to use the extension system in Kubernetes, and I can show an example of that here briefly. But I guess the thing that I want to get through today is to find out, to show you the advantages of using crew, to show you the process, albeit a little bit more involved to get something going, something uploaded to crew. And I'll take you through a couple of the examples that kind of sent me down this path. So if I switch over to terminal, I'll remember at this time to go back and forth. We have a terminal, and I'm going to use kubectl. Actually, let me go back to the browser, and I'm going to start with my first example. The first example that I'm going to bring up is also something that Adrian mentioned yesterday. I found this when looking at K8smear from Darkbit, and this is just a silly kubectl plugin example that shows you that you can you need to be secure with the way that you're doing kubectl plugins. So this one is just called kubectl honk. The process is pretty straightforward. Just curl it. That will download the repo, change mod to kubectl honk, and then make sure that kubectl honk exists in that directory. So I've already gone through the process of installing it. If we go to, let's do an ls la user bin kubectl user bin grep for crew. I don't have kubectl. Oh, user local bin. My bad. Cool. So I already have it located there, and you can see that it's the only plugin that I have listed. And if I go into, I should have a kubectl environment to use, kubectl get nodes. You can see I have a node with I have a cluster with 2 nodes. This, I believe, is my DigitalOcean node, or DigitalOcean cluster. If we do, one thing I want to do before I run kubectl honk is to take you guys through the process of what's there. In kubectl honk, you can see it's just a bash script. It's just showing you the version, that it has access to the environment, saying that it's got the ability to print out your kube config. That means it has access to your cluster. It has the ability to do gcloud stuff, access tokens, so on and so forth. So obviously it's very, very unsecure. But since that's all it's doing and it's not actually taking advantage of those credentials, I can feel safe to run it. kubectl honk. There you go. So you can see that it has access to that, Technically, I don't think I have the configuration directories for that, but I still would have had full access to my machine, basically. So that's well and good, but I think there's a lot of value. Well, I think there's a certain degree of value in having it publicly available through the crew index. And what the crew index is, you'll see if you go to crew.sigs.k8s.io, you can click on plugins. You can see a huge list of anything that's crew approved. And I say crew approved because the crew is maintained by the Kubernetes organization itself. And so it falls into things such as Prow, so that it's automatically picked up on the PRs and it's being observed by anybody who's a maintainer of the Kubernetes SIGs. A couple of the ones I want to point out, I think they may have shown up once or twice in previous Tool of the Days. There's obviously, well, I guess let me just point out some of the ones that I find interesting. There's Inspector Gadget here somewhere. Gadget. This one's going to be really handy. This installs Inspector Gadget, which is going to make use of the eBPF, so you can do some snooping of network traffic using your kubectl command. So if we look down here, I don't think I have the patience to wait for that to load up. No, I don't. But basically, you're just doing kubectl install gadget, kubectl gadget help. So if I wanted to switch back over to the darn it, I never switched back to the browser. I said I was going to be better at that. I'm improving, but not very quickly. So if I switch back to the browser, I'll take you back through the plugin index, crew.sigs.k8s.io plugins. Scroll down, you can see I think there's about 100 or so. Click on Gadget. That will take you to the Inspector Gadget repo. That's from Kinvolk. And if we go down, we can see that there's a pretty quick and easy install process. That's the main benefit of using Crew. If I switch back over to WSL now, kubectl install gadget. Generally speaking, when you install a Crew plugin, you'll see a list of things that have changed in the last time you've run Crew. You can see up at the very top, new plugins available, Flight, SOCKS 5 Proxy, and that I'm installing plugin gadget and the success of that installation. All of this other stuff is encapsulated within the specific Crew reference for this plugin. So this is something that if you wanted to submit to Crew, you have to manage and maintain yourself. So they add a link to their documentation. They show you how you use that plugin, and then they give you some caveats if there's any prerequisites that you need. So if we do kubectl gadget help, like they suggest we should, we see that we have the ability to trace IPv4, IPv6 bind system calls, capabilities. We do need to do the deploy step first if we wanted to use Inspector Gadget. It's not going to be able to do all of this from your own terminal. But let's actually go through that one more time. kubectl gadget deploy. That's going to dump out all of the Kubernetes manifests. So if you wanted to look at them, it's more or less a dry run command. There's a service account, there's a cluster role binding, there's a daemon set, and a couple other bits of information, just making sure that it's showing that the system permissions that it has. Cool. And so that's one way that you can also get things into your cluster. Other things that you could do with Crew are you could do kubectl crew help. We can see an index. We can do the install, which we just did. We can list everything that's in this environment. We could search for other things. Really, the main advantage of using Crew, in my opinion, is the fact that you don't have to bounce back out to the internet. If you're perfectly comfortable working in your shell, then in your shell you can stay. So if we did a kubectl crew list, we'll see that I have a couple crew plugins installed. I have gadget, get all, config, crew, namespace, cdx, create YAML. Then you can see the versions of each one of those. The one that I wanted to show today is one of the previous tools of the days. And if I switch back to the browser and I go to the right terminal window, you can see there's kubectl blame. kubectl blame we had in a previous show. That's going to make use of managed fields and give you the ability to attribute a change in a Kubernetes resource to a specific account in Kubernetes. I think this tool should get a little bit more visibility because managed fields is something that we talk about as being kind of in the way. I haven't seen too many people that are very excited about managed fields. There's plugins that are used to basically remove them from the output. And a lot of the user interfaces that you might use to interact with Kubernetes have them turned off by default. And ultimately, I think that Kubernetes should be able to, there's value in them. It's just a matter of getting the value out of them with the right tooling. And so I looked into this kubectl blame. Before I started, there was a GitHub Workflows action. There was the command. This is just a plugin that's written in Go. And there's a makefile. That makefile is something that I had to change when I wanted to submit it to the crew index. But without going into too much detail, there's an install step, just going to do the Go installation. There's a GZ releases step. That's going to create releases for everything. And then there's a SHA-256 releases, which is going to create the SHA-256 for each of the releases. If we go back to kubectl blame, we can see that there's the GitHub action is actually producing releases. It was doing that prior to my involvement. The changes that I made were just to make it so that you can get the SHA-256 available, and some of the structuring for the way that kubectl is the way that the plugin is being bundled. So the difference being, where's my crew? Let's go back to crew, Kubernetes. The requirements for adding something to the crew index start out with making sure that, where's the guy submitting plugins? Step one, make sure you name it right. The naming convention, if we look at the naming convention guide, is don't do the right casing. Be specific. Don't do anything that's going to collide with something else. So the example they give here is GKE login. If you did a generic login, that one you could overwrite AWS or Azure or something like that. You don't want to overwrite it with something that's available in Kubernetes itself, because that would be slightly confusing. And then the vendor information. So kubectl blame was pretty generic, and I think it met those criteria, so I didn't really make any changes there. If I felt like if I made any changes, it would probably just add to the verbosity of it, and I'm all about keeping things pretty straightforward. So step number 2 is to read the plugin best practices. I do want to point out that the people responsible for approving my crew report have been more than generous and more than patient with my process. I read through this document and I submitted it, and then they pointed me at the document again with something I missed, and I resubmitted it, and then they pointed me at the document again with something else I missed, and then resubmitted it. So I just want to shout out to them and say thank you for being patient. I can't imagine dealing with open source pull requests for people that are missing basic components is a very is a very good, enjoyable process. So the main things that I missed are I didn't have access, I didn't have control of the source code repository. So in order to submit a crew plugin, I have to fork the crew index, which exists here, which just has a list of all the plugins. All of the plugin. So I had to fork this repo alongside of the fork of the kubectl blame, and so I had to keep them in lockstep just to make sure that it abided by all of the necessary criteria. So this is something that's still outstanding. I'm going to open a pull request to add the Kubernetes client auth so that kubectl can properly authenticate with the, so that kubectl blame can properly authenticate with any of the clusters that it needs to. So far in my testing, it's worked with everything, but I guess there are going to be certain edge cases because I did not test it against every distribution of Kubernetes, nor did I test it against various versions of Kubernetes. Which reminds me, I should probably put in something that that limits the versions that you can deploy it on to versions that have managed fields. That's a to-do item. Going back through the list, I think the only other thing that I really needed to configure is, well, it's make sure your plugin source code is available as open source. That was already there. I already forked the repos. That's how I found it. Adopt an open source license. That license was already there, but I did have to restructure the package so that it does number 5. Make sure to extract the license file during the plugin installation. Going back to kubectl blame, that was a really easy transition. In the make file, there was the tar.gz. I just added the license file to that tar.gz. And made that available in each of the environments, or each of the plugins. Beyond that, if we go back to here, that takes us through step 6, semantic versioning. Semantic versioning was already enabled, like I mentioned. It just needed to pull in the proper configuration, the license files, and the SHA-256. Because when you test the plugin installation locally, that's when I really had to start doing things manually. So if you test the plugin installation manually, you can see that it's referring to a specific manifest, the foo.yaml. This is when I'll switch back over to WSL and show you what I did with that, how I created that in this environment. So if we go to CNCN Tool a day, episode 2, change directory to kubectl blame. We can see that I've got some cruft in here because I was doing some releases myself. Git reset. I'll look at the, oh wait, this is the wrong directory. I want to go into crew index. There we go. We'll see in the plugins index, this is everything that's publicly available, but the main difference is that there is now a blame.yaml. That blame.yaml is the file I created, and it's got a bunch of configurations in it. So this is going to look very familiar. It's a Kubernetes kind. You have the API version, you have the kind, you have the metadata, you have the spec. So the spec has the version. So if I wanted to keep track of this through the crew index and make it available, make updates available, or at least alerted in each of the crew iterations, that's how I would change it there. And then there's a platform section. Thankfully, the developer for the kubectl blame plugin already had deployed it, had created releases for Linux and Darwin. So those I really just had to fill out the required information. You can see that I'm extracting the license file, I'm extracting the binary, and then I just had to add the SHA-256 from the additional step I added in the make file. That is using a selector syntax because, like I said, this is using some of the native Kubernetes functionality. and there's a couple extra sections that I had to go back and forth to make sure that they fit the spec of Kubernetes of the crew index. There's the short description. The short description, originally I just copied and pasted it from the README, but that was a little bit too long, and so I had to trim that. The homepage is going to be Night42 because they're the person that owns this plugin. Caveats. Like I said, the caveat section is just to make sure that you're running in an environment that would support it. This could be where I would initially alert if your cluster doesn't support managed fields. This plugin is going to be meaningless. Don't install it. I might actually have to add an update to the usage section there too. And then beyond that, there's the description fields. The description field is where you have the more in-depth description. Then if the one last thing I want to mention, that if you want to submit your own kubectl plugin, you have to wrap everything at 80 characters, and ultimately that makes sense. It's just not something that I did. So to test that, I ran kubectl crew install, pointing to a specific manifest. I think it's already installed. Yeah, so let's kubectl crew. I think it's uninstall. Yep. Oh, it's just blame. Then reinstall it. So I plug and blame. You can see that I've added the or that it's got the documentation, the caveats from the plugin.yaml file. So now, if I want to do kubectl blame help, you can see the help that's being piped from the plugin itself. Let's blame on one of the things from Inspector Gadget that we just deployed, the daemon set. Kubectl get ds daemon set. Let's go gadget blame ds. And there we go. We have it as a plugin. I think this is going to be very uninformative for the moment. There's just everything's being done by kubectl client side apply. So if anything were being changed, I just saw Pop's comment. Those Kinvolk folks are money, in fact. So beyond that, so that takes us through the basic installation. I've got 5 minutes left. The original reason why I thought this would be a good idea is because also alongside kubectl blame, going into the K8s mirror project from this week, the way to deploy that and run that in your environment, it didn't seem that straightforward to me, and I wanted to make sure that I wanted to make it easier so that people either in this channel watching CNCN or just interacting with it had a quicker way to spin it up. It was easy and it worked as expected, but I think you can make it easier. So beyond that, let's actually take this for a quick spin. I know that's something that we haven't shown yet. So just to recap, if you didn't catch the episode, K8s mirror is going to take a copy of your current running environment, dump it to a local installation, scrub all of the secret information, and then give you the ability to inspect that from an API server locally. So I already have this cloned. Oh, I missed it again. Change directory, repos, K8s mirror. And we go to, let's cat the readme, clone the repository. We've done that. Run kubeexporter.sh against the target cluster, kube.sh. That runs for a couple of minutes, and we have the ability to look at that information. That's just going to be basically an etcd dump. Um, while that's happening, I guess we can wait. I haven't looked at the chat in a little bit. I apologize for that if somebody mentioned me. Okay, yeah, I'm glad that Nuno also agrees. They've been really patient. The K8S team has been really patient, and efficient too. I would say that nothing goes unresponded to for very long. So I guess it's taking a little bit longer than expected. Since it is coming up to the close, I want to, now that I am looking at the chat and making this more of an interactive experience, I want to ask if out of a given set of choices, what you guys would like to see beyond this, or for next episode. So the first episode, I focused on making things available with Helm. The next step I made is making things available through Crew. And I think a couple of the other steps that I can help improve upon are given tool of the days that are maybe cloud specific, extending them into other cloud providers. That would be option one. Option number two would be kind of spanning the gap from infrastructure admins to developers. One of the previous tool of the days was Kubevela. That was the ability to Kubevela was the ability to kind of template out specific resources without having to be a resource a specialist. And then option number three would be modifying things that allow for cluster visibility. One of the projects that I've worked on recently was EdgeNet, which was essentially the mega cluster. And that mega cluster had some ideas in it that I think could be expanded upon, and I've been working on lately to use something called node feature discovery to add some node labels that are meaningful in the mega cluster context. So to recap, if you want to add to Discord, add to the YouTube channel, a message that says that you'd either like option option A being the cloud agnosticism, making some of the tool of the days more cloud agnostic. Option two, developer focus with Kubevela, or option three, which is node feature discovery and making the concept of a supercluster more easier to use. So I'm actually, it's still taking forever to go through the cube exporter. It must be a larger cluster. This is the same experience I had yesterday. So okay, I guess to wrap it all up, one of the reasons why I don't think this would be a good candidate for a kubectl plugin is that, like I said, it does take a long time. It's generally speaking, with a kubectl command, I churn through them at a rate of 100 or so a minute. This would definitely be an interruption in my process, and I think it makes sense to keep this as a standalone project. All right. With that being said, I'll wrap it up. I'm hopeful that this was useful to people. I promise that next time I will be better at switching my windows. I'll keep track of what people in total want to see, and hopefully you guys come and see me next week. I had a great time doing this. Once again, thanks Adrian for allowing me the opportunity to run shows on Fridays. And I hope everybody has a fantastic weekend. So long, and I'm not going to co-opt the term stay caffeinated, but enjoy your weekend.